Cosmology 1, the history of everything.
We might be inside of a pocket universe, inside of a multiverse. The Big Bang was a day without yesterday. The last 13.7 billion years is the only time that we currently have access to. The 5 elements of ancient Greece are earth, water, air, fire, and ether. The 5 elements of modern cosmology are light, atomic matter, neutrinos, dark matter, and dark energy. To run the universe backwards to the Big Bang, imagine a giant piston compressing it. Telescopes become microscopes when examining the initial fluctuations that spawned galaxies. There's no way to speculate beyond about 10 to the minus 43rd seconds after the Big Bang because Einstein's relativity breaks down and gravity takes on a quantum form called Planck time. Space cannot be subdivided beyond the Planck scale. The universe that we know of has expanded to about 100 billion light years across now and is expanding faster every second. Below 1 trillion degrees, quarks bind to make protons. Below about 1 billion degrees, protons bind to make atomic nuclei. The very high temperatures in the first millionth of a second after the Big Bang caused collisions that created particle-antiparticle pairs. In the first microsecond after the Big Bang, there was an equal mix of matter and antimatter particles and photons. All of the protons in the universe were born about 10 millionths of a second after the Big Bang when they condensed out of the quark-gluon plasma. From about 10 microseconds to about 100 microseconds, there was a monumental annihilation of matter and antimatter. This matter-antimatter annihilation made the universe a few times hotter. We can tell by the ratio of protons to cosmic microwave background radiation photons what the original ratio of matter to antimatter was. It was about 1 part in 1 billion matter over antimatter. It was just a little bit more matter than antimatter. The reason for this is unknown. It's beyond the standard model of physics. 1 second after the Big Bang, the light in the universe outweighed the matter. Near 10 seconds after the Big Bang, spanning a few seconds, electrons annihilated with anti-electrons. The universe had to cool until about 1 minute after the Big Bang. Protons and neutrons could stick together. About 1 minute after the Big Bang, when the universe was about 100 billion degrees Kelvin, about 25% of the universe's hydrogen was converted to helium. That's 100 times more hydrogen being burned in that very brief time than in all the stars ever since. The universe at 1 minute old was less dense than stars. It was also expanding and cooling very quickly, so only fast reactions had time to get going. Slow reactions that can occur in stars never had a chance to get going. It probably took about 100 to 200 million years for the first stars to form, and another billion years for the first galaxies to take shape. The creation of new stars steeply increased up to about 2 billion years after the Big Bang. then it decreased slowly, probably due to the frequency of galactic collisions.